Good morning, students. Up to now, we have learned the various methods to find the HCF and LCM. In HCF, three methods and LCM, three methods we learned. Which in HCF is the first method is the factorization method. Second method is prime factorization method. Third method is long division method. Three methods. In the LCM also, choosing the lowest common method, lowest common multiple in the list of all the common multiples. Next one is the prime factorization method. Third one is the common division method. So three methods we learned in the LCM also. So by using those methods, you have to solve the problems in the exercise 3D. So here you see the first one. Using prime factorization, find the LCM of the following. Using prime factorization, find the LCM of the following. The first one is 24, 32, 90. So prime factorization means, as per your textbook, you have to find out separately all the prime factors of the given three numbers like this. So 2 12s are 24, 2 6s are 12, 2 6 are 2 3s are 6, 3 1s are 3. So this is over. Next take 32. 2 6 are 16s are 32, 2 8s are 16, 2 4s are 8, 2 2s are 4, 2 1s are 2. Take 90, 2 45s. Next 5 9s are 45, 3 3s are 9, 3 1s are 3. Now list out all the prime factors you got in this factorization. So now the prime factors of 24 are here 2 into 2 into 2 into 3. Take this 2 into 2 into 2 into 3. Next all the 2s here 1 2 3 4 5, 2 into 2 into 2 into 5 2s. Next 2 into 5 into 3 into 3 into 3. Write them as a list. Now you round up. First of all, you have to round up all the common factors first. Here 2 is occurring in three lists of the factors. So take round up all the 3 2's here. Here 2 is occurring in two numbers of the factors only. Okay, here 2 is occurring factors of the two numbers only here. Here 3 is occurring in the factors of 24 and 90. That's why I am taking and rounding up like this. And this 2 is not occurring anywhere, so leave it. This 2 is also not occurring anywhere in the remaining list of the factors, and 3 is also occurring one time only here. Okay, leave them like that. So now you have to take one out of these three and one out of these two. Okay, minimum 2 times they have to occur. Okay, if it is occurring only one time, you have to leave them and take as it is in the multiplication. If they are occurring minimum 2 times in the two numbers, you have to take them. Okay, maximum 3 times if they are three numbers, minimum 2 times they have to occur. Then you have to take one out of them only. So one out of these three numbers is this 2. One out of these two numbers is this 2, and one out of these two is this 2, and one out of these 2 3's I am taking a single 3 here. Okay, and remaining numbers which are not occurring anywhere 2 times, this 2 2, this 5 and 3 are there. I am taking all these numbers as it is here. This 5 and this 3 and this 2 and this 2 I am taking as it is. Okay, so now you have to multiply. Whatever the numbers are occurring 2 times or more than 2 times, you have to take one out of them only. Okay, that's the rule you have to follow. You have to take one out of them only. Here, out of these 3 2's, you have to take only one. Out of these 2 2's, you have to take only one. Out of these 2 2's, you have to take only one. Out of these 2 3's, you have to take only one 3. And whichever are not occurring more than one time, you have to take them as it is. I am taking as it is and multiplying them. So by multiplying these numbers, you will get 1440. So this is the LCM of 24, 32 and 90. Okay, so this method you have to understand like this. Okay, next one 28, 74 and 140. take individual factors. So 2 14s, 2 7s, here 7 1s are 7. Here it can be divided by 2, how many times? 37 times. And there are no other factors for 37 except 37 and 1. So 37 1s are 37 and leave it. Okay. Next here 2 70s, 2 35s, 5 7s, 7 1s. Take them as list here. So prime factors of 28 are 2 into 2 into 7, here 2 into 37, here 2 into 2 into 5 into 7. So now take all the common factors and round them like this, round up. So here 2 is occurring 3 times, round up. Here 2 is occurring here and here, round up. Next here 7 is occurring here and here 2 times maximum. Okay, and 37 is occurring only one time, and 5 is also one time. Okay, that's why you have to take them as it is. So now out of these 3 2s you have to take 1 2. Out of these 2 2s you have to take 1 2. Here out of these 2 7s you have to take 1 7, and remaining 37 and 5 you have to take as it is and multiply. You will get 5180 if you multiply all these numbers. So this is the LCM of the given 3 numbers. Okay, next one. Third is 128 and 48. Here also you have to take all the prime factors and list out them. And after listing out them, you have to take the common factor and round them. Out of these two, 1, here 1, 1, 1, 2. Remaining all the numbers, these numbers are occurring only one time here. No 2's are there here. Here 3 is also only one time. So you have to take as it is like this. These 3 and these 2's and multiply them. So you will get 384 as the LCM. Okay, next. Using prime factorization, find the HCF of the following. Using the prime factorization, find the HCF of the following. So prime factorization means here also I am taking separately the prime factors and finding out the HCF here. Okay. See the first problem here, 256 and 96. So here you can solve this problem by using two methods. In the prime factorization method only, two methods are there. Finding out the prime factors separately, like in LCM, already explained you. And you can take the common division method using the prime factors also. You can use both the methods are prime factorization methods only. Here you are finding out the factors separately. This method you used in the 5th class. That's why I explained this in this previous method, and also I will explain the common division method also. That is very useful and easy method also. Listen here first. So the first method is here finding out the prime factors separately. So take the numbers individually, find the prime factors. 2 128s, 2 64s, 2 32s, 2 16s, 2 8s, 2 4s, 2 2s, 2 1s. Next, 2 48s, 2 24s, 2 12s, 2 6s are 12, 2 3s are 6, 3 1s are 3. So now list out all the numbers like in LCM. Okay. After listing out, here also you have to round up all the common factors. 2 2 2, here 2 occurring 2 times, and whatever the numbers are not occurring commonly, you should leave them. You should not take in the product of the factors here. But in LCM, you have to take one out of all these numbers, and you have to take the remaining numbers also to multiply. Okay, but in HCF you have to choose only one out of these common factors, and remaining numbers you have to leave them. Okay, that's easy also. So one out of these two is here 1 2 3 4 5, 1 2 3 4 5 2's only you have to take here. So 2 into 2 into 2 into 2 into 2 is 32 only you will get here, because you are leaving all these numbers. So this is the HCF of 256 and 96 by using the prime factorization method, by taking the prime factors separately. Same problem we can do 256 and 96 separate by taking the common division method. This is 256 and what is this here? 96. 256 and 96. Now I am taking common division method. So here 128 times here 2 4s 2 8s, commonly dividing with the prime factors. 2 6 are 12, 2 4s, 2 2s are 4, 2 4s. Next 2 3s are 2 2s. Next 2 12s are 24. Next 2 16s, 2 6s are 12. Next 2 8s are 16, 2 3s are 6. Here we have to stop because both the numbers 8 and 3 are not divisible by any one of the prime factors, prime numbers which are 2, 3, 5, 6. You cannot divide both the numbers at a time. You can stop here. Up to here only you have to take. Okay. So now it is 2 into 2 into 2 into 2 into 2, which is 32. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. Same answer you are getting. This is called as the common division method. Okay, this is another method and easy method also. Common division method. You have to divide both the numbers with a common prime factor. Okay. Okay, after getting the numbers which are not divisible, both the numbers are not divisible by any one of the prime numbers, you have to stop here and take all the numbers, all the prime factors you are getting in the left side and multiply them. Which is same number you are getting 32 here. Okay. Next one 210, 100 and 63. Here also I am taking separately all the prime factors here. 2 105s, 5 21s, 3 7s, 7 1s here, 2 50s, 2 25s, 5 5s, 5 1s here. Here 3 21 times it will divide. 3 2s are 6, 3 1s. Next 3 7s are 21, 7 1s are 7. List out all the numbers. Out of these three commonly occurring numbers, observe here 2 is occurring only 2 times. There is no 2 here. 5 is occurring here and here only 2 times. That should occur in all the three numbers. Like in LCM you should not take minimum 2 times. Okay. Here also not there here. 3 is only here. 7 is only here and here and here only. There is no 7 here. So there is no common factor for above 3 numbers. 1 is the only highest common factor for all. Okay. Only you can divide all the 3 numbers with only 1 only. Okay, that's why if there is no common factor is there, you have to take the HCF as 1 only. That's you have to remember. Therefore, HCF of 210, 100 and 63 is only 1 here. Okay, since there is no common factor for all the 3 numbers. If you want to divide them like this also, you cannot divide them because there is no common factor like this. Only you can divide those 3 numbers with 1 only. Okay. So what are those numbers here? 210, 100 and 63. If you write them like this, 210, 100 and 63, and if you want to divide them, there is no common prime factor for all these things. Only 1 is there. 1, 210 times, 100 times, 63 times. That's all. Stop here. So now what is the common factor for all these 3 numbers? 1 only. Therefore HCF is 1. So like that you have to find out by using this common division method. Okay, next one. 26, 80 and 390. 26, 80 and 390. Take the individual common factors. 2 13s, 31 ones. 2 40s, 2 20s, 2 10s, 2 5s, 5 ones. Here 2 ones are 2, 1 will be there 19, 2 9s are 18, again 1 will be there in the remainder, so 10, 2 5s are 10. Next, here you can divide this with the 3 table because 9 plus 5, 14 plus 1, 15, 15 is divisible by 3, so 3 6s are 18 here maximum, 1 is the remainder 15. 3 5s are 15. Next 5 13s are 65, 31 ones are 13 ones are 13. So now take all the numbers and list out 2 into 13, 2 into 2 into 2 into 2 into 5, 2 into 3 into 5 into 13. But only this 2 is common for all the list of factors. There is no other common number here. 13 occurring only 2 times, but it should occur 3 times in HCF. But in LCM we can take, if they are occurring 2 times also, maximum we can take. That's the difference. Here 5 occurring 2 times we can take in LCM. But in HCF it should be in lists of 3 numbers. Okay, then only hard to take. Only 2 is there commonly in the 3 lists. Okay, so 2 is the HCF. Simply 2 is one out of these 3 is 2 is the HCF. Okay. Now if you want to take the common division method, 26, 80, 390, 26, 80, 390, you can divide this with 2 only. Okay, 2 13s, 2 40s, here 2 1s, 2 9s, 2 5s. There is no common factor for 13, 40 and 195, so you can stop here. Okay, so now 2 is the HCF here. So this is the common division method. 2 is the HCF here. Next one, third, find the HCF of the following using long division method. So here you have to use the third method, which is long division method. 20, 60 and 108 I am taking. So first I am taking 20 and 60. So 23 is 60, 0 you are getting. So 20 is the HCF of 20 and 60. Now take this HCF 20 and divide the third number again. 25 is 100, 8 is the remainder. Now divide this 20 again with this remainder 8, 8 2s are 16, 4 you are getting. Again you have to divide this 8 with 4. Okay, you have to continue this procedure. Okay, so take this divisor and divide this with the remainder 4. So 4 2s are 8. Until you get this 0, you have to continue like this. So now you got 0 here. Wherever you are getting the 0, that divisor itself is the HCF of the given 3 numbers. So now 4 is the HCF of 20, 60 and 108. Okay, so this is the answer. Next 98, 28 and 56. First I am taking 28 and 56. 28 is 28 2 times it can divide. 28 2s are 56, 0. So now divide this 98 with 28. 28 maximum 3 times 84, 14 you are getting. So now divide this 28 with 14. 14 2s are 28, 0. So 14 is the HCF. 14 is the HCF here. Next 51, 170 and 510. So you can divide 510 with 51 easily 10 times. So 51 tens are 510, 0. Now you divide this 17 with 51. So 51 maximum 3 times 153 are getting, 17 is the remainder. Now you divide this 51 with 17, 17 3 is a 51, 0. So since you are getting 0 here, 17 is the HCF. So 17 is the HCF. Next, find the LCM of the following using common division method. So common division method means you have to divide the common factor like this. So to start with 2 first, which is the first prime number. So you cannot divide 21, bring down. So this is 2 18s. Here this is 254 times here. 2 5s are 10, 2 4s are 8. Next again bring down 21. 2 9s are 18. Here 2 27s are 54. Next you cannot divide any one of these three numbers with 2. Now go to 3 here. Next prime number 3. So 3 7s, 3 3s, 3 9s. Next maximum these two numbers can be divisible by 3. So choose 3 only. So bring down 7. 3 1s are 3, 3 3s are 9. Next here you can choose any one of these two. So bring down 7 1 and 3 1s are 3, and now take 7 7 1s are 7 1 1. So you are getting all ones here in last row and then multiply 2 into 2 into 3 into 3 into 3 into 7. By multiplying them you will get 756 as LCM. Okay. Next one 22, 14 and 110. So here 2 11s, 2 7s, 2 55s. So these two numbers maximum divisible by 11. That's why I am taking the 11 here. 11 ones, 7, 11 5s. Here you can take any one of the prime numbers. 5 here I am taking 5. Bring down 1 here. 7 bring down 5 ones. So 1 bring down 7 ones. So, 1 you have to bring down. So you are getting all ones here. Multiply 2 into 11 into 5 into 7, which is 770. Next 260 into 39 and 260 and 39 and 78. So try with 2. 2 130 times 2 13s are 26. That's why 2 130 times 39 bring down. Here 2 39 times 78. 2 3s are 6. 1 will be there remainder 18. 2 9s are 18. Next here if you observe 13 table you can take, because all are multiples of 13. 13 10s, 13 3s, 13 3s. Now you can take either 3 or 5. You can take, I am taking 5 here, 5 2s, bring down all the 3s. Here I am taking 2 2 1s, bring down 3s. Here I am taking 3 3 1s 1s 1. Okay, now multiply. 2 into 13 into 5 into 2 into 3 is 780. So this is the LCM of given numbers. Next, fifth one, what is the greatest number which exactly divides 110, 154 and 242? Greatest number which exactly divides means that will be the highest common factor only, which will divide exactly, and which is the greatest number. So you have to find out the HCF. To solve this type of problems, the greatest number which exactly divides means that itself is the HCF only. So that's why you have to find out HCF of the given numbers. If here we are using the common division method, you can use any method. Here I am using the common division method. So 255s, 277s, 121 times here. Here 11 table you can use. 11 5s, 11 7s, 11 11s here. Here you cannot divide any one of the number with commonly with any one of the common factor. So leave it. Stop here. 2 11s are 22. So 22 is the greatest number which exactly divides all the three numbers 110, 154 and 242. So up to here I would like to conclude this session, and I will explain the remaining numbers in the next class. So good day to all of you.